So, hello everybody. Welcome to the talk about 3D printing. Please greet our talker and let's start.
Hello everyone, ili dobar dan svima. My name is Djordje Markovic. I'm infrastructure, process and plant manager in company 3D Systems, worldwide leader of 3D solutions. I would say we manufacture the printers, the software solutions, the scanners, and everything what allows us to realize the model, real 3D model from a 3D sketch. Today, if my presentation will work, we're gonna talk about 3D printing. What is it? How it works? What kind of materials, machines we have? And come on, please. Well, what is the point of 3D printing? The point of 3D printing is to come from virtual 3D model to the real model. And the application of 3D printing started for big industries, for a lot of different parts of industry, of car industry, of electronics, of sport equipment, health, education. And we started to democratize the solution, and now we are able to have the small 3D printers even for every home, and you can even print the toys for your kids. The big importance of 3D printing is to realize a real model and validate the concept. It means when I will design something, I'm in car industry, I want to design some part for the cars. On the screen I see it in 3D, but once I print it, I can really see all errors, possible errors I could make, or even all things that I could I have to do modification of it, just because to have the validated part. After that, we started to go further in the electronics. For example, we have the cell phones. We make the design of our cell phone, we put electronic inside, we validate the concept, and once we make the hardware of our cell phones working properly, we can start the serial production. So it is kind of intermediate stage between development and industrialization. And it can save us a lot of money, because once we make some errors and we discover them during the production process, unfortunately, we lose a lot of money. And for sure, oh, fuck. Yeah, never mind. About the subjects, I would like to talk about beginnings of 3D printing, because we started to talk about a couple of years ago, but 3D printing technology exists for 30 years. Well, since 30 years we are printing in plastics, in metal, and now we are even able to print in chocolate or sugar, in colors or monochrome. Also about how it works, 3D printing, how we print in 3D, what is the secret, what is the main procedure, what is the principle of 3D printing, about the printers, and all interesting applications of 3D printing. Let's start about 3D printing, how it works. Well, you will see the liquid plastics and UV laser that will polymerize layer per layer. After every layer, the platform with built hard plastic goes down, and it makes us the final model. The technology is named stereolithography, and we use the photosensitive polymers. This stereolithography technology is very used in car industry, because for big parts, the real size parts of the cars, trucks, planes, and everything else, we can make quickly the real models and mount them on the cars. For example, all new prototypes of very luxury cars are presented with a lot of printed paths, because we can paint them, brush them, polish them. We can do a lot of things with. And as we have different type of plastic materials, we can really present a nice and functional prototype. We can print with the liquid materials. I mean, those materials are liquid plastics sensitive to UVs. Or solid materials, but solid materials are plastic powders, and we melt them layer per layer. The main principle of 3D printing is we print the layer per layer. If you cut the circles and you put the circles, you get a cylinder. 3D printing is same. So technically, it's not a very complicated process. We can also, please. Here is how it works with powders. Here we have a thermic laser who will melt the plastic, layer of plastic. Then we come with another layer of plastic powder. We will melt it up to end of the part. And in a couple of hours, we have our part finished. About price range, we have 3 groups of printers. We have the personal ones from 1,200 euros up to 20,000 euros. We have professional machines used mainly by engineers, architects, people who will make the concepts, who will make the projects before industrialization. And we have production printers. That means with those big machines, we manufacture the parts that we will mount in different industry fields. For example, General Electric has something like, I would say, 40, 50 3D industrial printers. Yep. Otherwise, all big industrial leaders are also equipped with printers. Formula One teams also, every Formula One team has 3D printers. When they have some idea to make some design, some new aerodynamic parts, they just they draw it in 3D with some CAD tools, and then they print it. They can mount it on the Formula One, they can check the shape, put it in the wind tunnel, and really increase their performance of aerodynamics. Otherwise, when we make some parts for the planes or cars of any industry, we do the same. Next slide is about the clients and range. When the hammer to break something is only a way to do the things, then we go to 3D printing. Somehow, some parts are not possible to be done by conventional working methods, and we need to print them. Because advantage of 3D printing is there is no limits. As we make layer per layer, that means that we can imagine the sphere in the sphere, and we can print sphere in the sphere, and it's one part. Otherwise, we can also print complete assemblies that you can move, and it's only one part. You cannot disassemble it. You need to break it. Otherwise, you would need to spend a lot of time to make this by milling, drilling, and other conventional manufacturing methods. Please. Okay. The man on the left side is Chuck Hall, the father of 3D printing. Chuck Hall, in '86, had idea. He was working with photosensitive coatings for normal 2D printing, and he discovered then with UVs he can put layer on layer. So he designed first stereographic machines, and he started the 3D printing career, 3D printing revolution. During those 30 years, we got in our portfolio big clients, big companies like GM, Honda, Airbus, Toyota, BMW, Fluke, 3M, Videx, Siemens, and all other industrial companies using our printers. Even the ear plug devices now are printed, the plastic part are printed. So we just put electronics, and we can customize earplugs for every ear. Like this, we have more comfort, and better efficiency of healthcare devices and equipment. Otherwise, yes, Pratt Whitney for plane engines. About the parts that we can print with 3D printing, we can really have the small and very complicated parts. And till one certain amount of those parts, we are cheaper to manufacture them with 3D printers than with some serial production methods. We can also, as mentioned before, make car parts, the plane parts, the prosthesis. Also, we can print in the waxes, and we can use this for lost wax molding. That means I can design for my wife, for example, a ring, if I will ask her for a wedding, and print it in the wax. After that, I can make a small sand mold, and I have my master part. And also, I make my custom-made jewelry, whatever I want, and I melt the gold, and I create my ring. I polish it, and it's done. A lot of Oriental jewelry companies are working with those methods to manufacture, to make for their clients custom-made parts and really designed parts and unique parts. About biocompatibility, we can use our materials, parts printed in specific 3D materials can be used in operation rooms. That means we have some specifications that we need to respect about the cleaning, bacteria, all those stuff, and we can really use them in the operation rooms. Concrete example: I had surgery, orthopedic surgery, asking me, can we make the specific drill machine guides that will allow us to drill the bone on a specific angle customized to the patient. That means we scan in 3D the bone, and after that we design the part adequate to his leg and his bone, and to just to fix something in specific position decided by doctors, surgery, medicines, and all stuff. And it was possible. And I will also talk a little bit about small 3D printers. The printers you can have for your home. Those printers are working with very simple method where you have just a roll with ABS or PLA plastic. It will heat and melt your plastics, and then layer per layer we can design the parts. It's a perfect solution for to start with 3D printing. We can even manage a couple of colors, so we can even make a mix of 3 or 4 colors. For some unique parts where we will just show the shape of the part, it's a very cheap and efficient technology. And what is also interesting about this kind of personal printers, there is heaps of open source machines. That means I will give you after that some websites. You can really order the kit and how to do, and you can really make for less than 500 euros your own printer. I mean, with 2 normal 2D printers, you can make one 3D printer. And it's a beginning. It's already something you can design, for example, your house or whatever you want, and you can print it and you can have it in your hand. Otherwise, with same principles, we can even print the sugar, even in color. That means if you have some wedding cake, as normal wedding cake, you can scan your bride and the man, you can print them in the sugar, and then after that the lady eat the head of the guy after the wedding. So or chocolate, you can even play with, if you're some kind of creative person, you can play with flavor of your chocolate and design the parts in chocolate that you will eat after. with in relation with the flavor of your chocolate. Otherwise, we can also print with 396 colors, and we use these kinds of 3D printing for architects use this to present the quarters, the buildings, the houses. Before we had the guys they were making the models of the house, of quarter and all the stuff, and it was a painful job. Now we have 3D drawing, and we just print it with colors. And in a couple of hours, we have the presentation of how it looks like our new house or our new flat. We can even manage where we were gonna put the living room, the bedroom, all those stuff. You print, and the final client who will buy the house can see perfectly how it is, how they arrange the things, and where he can do some modifications and all. It really gives us another vision of the future. Next. About open source printers. Here are some of websites where you can find really all informations about those printers. The RepRap is one of the first one. MakerBot, it's kind of, yeah, they started like open source, but then came also the professional part of the story, and they also try to get some money and make some money with this. Event or Bot, 3D Hubs, all of those websites gives you the tutorials how to create your own 3D printer for cheap. To print with 3D printers, you need to have STL files. So if you have some CAD software, there is also a free CAD softwares you can download for Linux, for example, FreeCAD, or even for Windows or Mac, it works perfectly. You can design your parts, and with a couple of hundreds of euros, you can have your own 3D printer. Unfortunately, this time I wanted to bring one printer, but as I came on holidays and all those stuff, I didn't really have a place in my car to show you how it really prints in the real time. But for next year, why not? The schools, now we start to print in 3D since 7 years. When we start to go to school, everything changed a little bit, and now we start to work with 3D printers. It helps to the people to understand how it works, and it brings also a view out of the box. It really, yeah, we can really learn how to see the things differently, and the things what were not possible before, now they're becoming possible, and it starts to become no limits. I showed you a lot of parts made in plastics, but we can also make metal parts. And the big industries are investing a lot of money in metal parts. It's also the metal powder, stainless steel, hard metal, titanium, and other noble metals. We print them also. When I say print them, we don't print them. We have also the powder. We have thermal laser who will melt layer per layer. But the tuning of the laser, the strength of the laser, and all those stuff, it's really a little bit fine-tuning stuff. And for sure, for schools, architecture schools, engineering schools, universities, now we start to have in every school a 3D printer. And it helps a lot. When you're a mechanical engineer and you design a gearbox and you print the gearbox and you can check how it works, where you can have the risks, you can make a real study with a real functional model. It helps a lot, and it makes in the manufacturing time of the thing much, much faster. Otherwise, here I have one nice example of baby seat. One is molded, like all seats you can buy from 50 euros to 500 euros. Second one is printed in plastics. If you see shock absorbing graphics, you will see that both are identical, 100% identical. Okay, you will say for serial manufacturing, what is the use of, why should you print? It's more expensive and all. When we have special requests for the children or for the people who need specially ergonomic parts, it's much cheaper and faster to print it than to manufacture it with industrial methods. When we make it with the left side technology, we need to have minimal quantity of parts to have a reasonable price. Here, if we make 1 or 500, the price per item is identical. It just counts the material and time you used for this. Otherwise, we have, for example, conventional VS3D printing. Same part with same function. You have the air passing through the part. With conventional methods, you need 4 tools. You have non-standard parts, you have standard parts, you have glue, you have assembling work, and it takes more time and it's more expensive than directly printed part. There is no tools, there is no standard parts, there is no glues, nothing. Real application of all this, it's cooling systems of electronics in combat planes. As they have a lot of electronics left, right, up and down, you need really to have ventilation with very complicated pipes and parts. Well, with this kind of methods, you need 10 days to make final part. With 3D printing, you make it in 1 day and you just mount it in the plane. Airbus started to use these kind of technologies to make non-functional, to realize the non-functional parts of the planes. So when you will fly it in the new Airbus A320 series, you will have 3D printed parts. Some the holders, the brackets, and all things that don't concern the structure of the plane, and all are printed. It goes much faster, and we can make the lighter parts. About materials, we can have really a wide range of materials, and we can have also reinforced materials. Plastics with metals, plastics with carbon fiber, with nanoparticles, with with glass nanoparticles, and for 1.5 kilo per cubic decimeter, we can have really, really rigid and resistant parts. As resistant and rigid that we will mount them in Formula 1 and go on the races with them. Okay, maybe Formula 1 is example of expensive technologies, but at least it's possible. And we don't need to have 25 hours a day to finish the part and to put the part in the on the Formula 1 before the race. We just print it and let's go. Even the Navy, American Navy, Russian Navy, they have metal printers for the metal parts on the ships, and they print the spare parts. If they have all spare parts they need during their during 1 year they spend over the sea, one part of the place is just for spare parts. With printers and a couple of types of materials, you have just the minimum of you use just minimum of space, and you can print whatever you want. If you need some screw, you print some screw. If you need some axes, you print some axes. Even now we talk even about titanium printing and implementation in human body, and we are going to achieve this moment also. And healthcare is really in big progress with 3D printing solutions. Otherwise, I think that you can see in the healthcare kind of equipment we can print. So if you earplug, all body is completely printed. hand support also printed. The prosthesis printed. We printed also for one dog who didn't had a problem with legs. Two front legs. He couldn't never walk with them because they were weak and cut. I think you can even find the clip on YouTube. And we printed the prosthesis for the dog. And dog with those 3D printed prostheses started to run and to enjoy the life as never before. So even for a pet, he has a problem with something, you can try to find a way to resolve the problem with 3D printing. Dental industry also. Now for the prosthesis, if you don't take the print of the tooth anymore with this kind of rubber and chewing gum and all that stuff, we scan with 3D, with a 3D scanner. Once we scan it, we print the teeth, and then we can really make custom-made prosthesis for this person. Because everybody has his own morphology, and with those technologies, we will really adapt all repair kit tools for to the person. And like this, you can have better results, and finally, we are humans, and if we develop some sciences and technologies, it's a good way when it serves to the human, to improve the capacities of human, not to kill other human. Otherwise, you heard, I think, the big boom of 3D printing is the guy who made his gun with 3D printing. It's more or less fake. I mean, you can print some parts with your small 3D printer, personal 3D printer, but after first shot, it will explode in your hand, it cut your hand. So you can really print a couple of decorative parts. And I think that healthcare equipment is much more interesting than manufacturing of guns. Otherwise, now if you have any questions, because I don't know, maybe yes.
You have to do some support.
For sure, yeah.
You can't drop to space anything.
Well, the supports that hold the parts, with stereolithography, the supports are made in same material than the part. So you need to remove them and clean with solvents. Once you clean with solvents, isopropylic alcohol or acetone or methoxypropanol, whatever, you just you cure the part in UV kind of UV box with the UV lights or mercury lamps during 10 or 30 minutes, depends of the part. And when you have this kind of post-process work. If you work with real 3D printers who print through the print head, then you have your support is the wax. So you just put the part in the oven, the wax is gone, and you have your part. When we talk about the powders, metal or plastic powders, you just take out your part, you use just a little bit of compressed air, and it's done. That's why the new boom in 3D printing industry technologies are stereolaser sintering, where we melted our plastic powders with laser. Because once you finish your part, you just rinse it a little bit and you just mount it and next one.
Is it a solution 4D printer or 5D printer? What's your opinion? 4D printer, 5D printer, what's your opinion?
4D printer and 5D printer.
Is it possible to have two nozzle in this two nozzle in this 3D printer?
Well, it is, but it's not useful. I mean, my opinion is you make it layer per layer. So imagine whatever you want like part, you just cut it into slices, slice it. So you don't need any nozzles. You have one nozzle up or one laser who will just make hard the layer, and it's done. It's not CNC machine. When you need to mile something or to drill something, you need to search some angles. But here, my layers are up to 18 microns per layer. So you can just move the layer per layer, your hole is just moving and you have your angle. I mean, you don't need really to think about 4 and 5 axes. When you work with some CNC machines, then yes, but here, everything is just layer per layer. So, and layers can be whatever you decide and imagine.
Thank you. Thank you very much.
Ah, you're welcome. Other questions?
Okay, so I'm specifically interested in personal printers.
Yep.
And I have tried some of them, and I'm just wondering, have you tried MakerBot, and is that better than anything else? Is it worth like throwing a few thousand more just to have it?
Well, I mean, all of them have the more or less same problem. The problem of them is first layer on the plate. You need to put some glue or something that will fix the first layer to the platform. And the problem is all of them are opened. So the most of them are opened. So you need to print with ABS. You need to have completely controlled temperature around 70 to 75 degrees. The most of the people don't do it. First, who was the leader of this kind of printers for even industrial applications is Stratasys. And all Stratasys printers are closed. All around is closed, and you can have nice parts. About open source printers, I think that there is no big difference between concurrents, you know. I work for 3D systems, so I work with cubes. I work with cubes. I have a couple of cubes and just for tests and for presentation, and for sure even first cubes had the same problem. Now new ones are closed completely and it works better. My final answer would be any printer, personal printer you imagine, have it just closed and with controlled temperature around the nozzle, around printing area and volume, and then it will be okay.
Okay, and do you have a space here in Novi Sad where people can come in and print something, or?
No, not really. Unfortunately, there is a couple of workshops with small printers in Belgrade, but Serbia is really, unfortunately, not yet the country where the people from here want to invest in 3D printing solutions. Unfortunately not. We have some professional machines in Croatia, in Slovenia, about Balkans, but here in Serbia, unfortunately not yet. It will come, I think, in a couple of years, but to have this kind of technologies, I think that you need to have a big industry and industry in progress, developing industry. With the industry we have here in Serbia, I don't think that this is really something that will come in next few months.
Thanks.
You're welcome.
Hi. So I have a question. So what's the smallest possible size of 3D printing, and is there any use now in nanomaterials? And
well, about stereolithography process, there is a nanostereolithographic process. So in 0.18 millimeters, you can print Formula 1, complete Formula 1. This is kind of smallest parts you can really print. We can print really nano parts. And about the main big parts, we can print the parts of 2 meters by 1 meter without any problem. So it's really wide range. And about nanoparticles, we put in plastics nanoparticles to make the plastics, to increase the performance of the material, to have the stronger material resistant to the bigger, higher temperatures. For example, one of materials we manufacture, you can work with 230 degrees. It's a plastic material, but you work in 230 degrees Celsius degrees of temperature. Some of companies that make kind of particular sensors are using them to take the measurements of pressure, and they use the 3D printed bodies to put electronics, and it will go in some 230 degrees atmospheres or 150 degrees atmospheres during the measuring time. And it's the machines that have this kind of sensors are running 24 hours per day. So yes, when we play with those nanoparticles and all the stuff, we increase the performance. We can increase the rigidity, the temperature, and yeah, we move a little bit the possibilities, because when you want to use make injection of some high temperature materials, everything costs. The mold costs, the machinery, the material. And sometimes you need some small series of 10, 15, 20 items. So 20 items, you need to create the mold and everything. Your bill is very, very high. You print them, okay, maybe you will print them for maybe 100 euros per part, but it's still cheaper than to make complete industrial process for 10 or 15 items or 20 items. And about manufacturing with 3D printers, there is a graphics, you know, you can calculate till how many parts you are cheaper with 3D printing, and from where you need to think you should consider other methods. Some parts, some small complicated parts, you can make a lot of them in 3D printing before you start to make them with conventional manufacturing methods. For example, medical devices, medical tools, the knives, the scissors, and all those stuff, you print them now in stainless steel. If you need some, if you have some surgery tools, special surgery tools, if you don't print them, first of all, you cannot make all shapes you want. So here we have really possibility to make something real custom made. And there is no limit. Okay, I cannot reach this angle because I cannot make it. I just make whatever I want. And I have it faster. And these kind of tools, for example, the quantity you can make with 3D printing before you consider serial manufacturing is big. Other questions? So many thanks.